I give you this function, y equals 2x minus 3. And I tell you the domain is 2, 3, 4, and 5. Well, in order to graph this, you're probably going to need to know the range. So if the domain is 2, 3, 4, and 5, what's the range then? How are you going to find the range? Plug in 2 for x. 2 times 2 is 4. 4 minus 3 is 1. 3 times 2 is 6. Minus 3 is 3. 5. 7. The domain is 2, 3, 4, and 5. The range is 1, 3, 5, and 7. So if you know the domain and the range, how are we going to graph the function?
Domain is x and range is y.
Oh, domain is x, range is y, so you have pairs of numbers, coordinate pairs. 2, 1, 3, 3, 4, 5, and 5, 7. So you could go over 2 and up 1 for our first coordinate pair. This is 2, 1. Then we'll have 3, 3. So we'll go 1, 2, 3 over, 3 up. Over 4, up 5. Over 5, up 7. And you'd have your graph, you'd have your function graphed. Now, do we need to draw a line through those 4 points?
Yeah.
No.
Not allowed.
No. Do not draw a line through those points. And the reason is this. If you drew a line through those points, then what you're telling me is that you're allowed to plug in any x that would be along that line. Any x that would give you a point in that line. What x's are you only allowed to plug in? The domain. Since I told you the domain is 4 specific numbers, then you should graph 4 specific points. The domain tells you what you're allowed to plug in. So you should only be allowed to graph those points that go along with those numbers in the domain. Okay? If I told you the domain was any x that's bigger than 0, then you could graph every x that's bigger than 0 by drawing a line through them. If through the x's starting at 0 and going up. But since I gave you 4 specific numbers, you should have 4 specific points, not a line drawn through them. That represents all the numbers. Label axes, so you know what they're talking about, and especially if you decide to go with a label, or you decide to change the scale of your graph by a count other than ones, you definitely have to make sure you label each space, or at least tell me what you're going by. If you change the scale, you need to tell me what the new scale is. I counted by 1, so I just go count by 5, 10, 15, 20. So you could, one thing you could do is you could just look at this and try to come up with a rule. Just look at what's being graphed. Some people, that's not always the best. Some people see patterns and numbers better when we write the numbers out. So it's not a bad idea to write out, just to make a quick table of our values here. So for our first point, what's the coordinate? What's the x value of this first point? 0. And then what's the y coordinate? 5. Over 0, up 5. And then we go over 1 and up 4. And now we go over 2 and up 3. Now we go over 3 and up 2. And over 4 and up 1. Is numerically what's going on with this function. Okay. So now the question becomes, what's a rule? How can we link y and x together? If you know what x is, how can we come up with y? Does anyone have a suggestion? One rule, one thought, one place we could think to start would be, let's start at 5 and then work our way down. For every time we add 1x, then we'll go down by 1y. So one way you can check your rule is if you came up with one is say, well, let's plug in x into our formula and see if we get the y. So what's 5 minus 0?
5,
What's 5 minus 1?
4,
What's 5 minus 2?
3,
5 minus 3? 5 minus 4?
1.
Hey, how about that? This seems to be a pattern that holds. Now, another way to write this might be to say, well, we first of all notice that as x goes up 1, then y goes down 1. Or you could say that as x goes up 1, you could subtract 1 x's. You could say I take x and subtract it by 1, or multiply by negative 1. And then where do we start? Where's the starting point? Well, what happens when there's no x's, or x is 0? What's the value of y? When there's 0 for x, how many y's are there?
5.
0 for x, there's 5 y's. So you could, another way to write the same formula, maybe a more like step-by-step approach, might be to say, well, let's see how does y change as x changes, and y goes down 1 for every x. Down 1 for every x. And we started at 5. All right, last but not least. The graph shows the average number of video rentals per month at a video store from 2000 to 2006. First, let's identify the independent variable and the dependent variable. Where we look on a graph or a chart to find the independent variable. You should know this from your science course, from graphing your data in your most recent lab. Where do we put the independent variable? The x-axis is where we plot the independent variable. So in our situation here, what is the independent variable then? Year since 2000. That's our independent variable. So then what should be the dependent variable? What depends on the years since 2000? The average number of video rentals is the, whoops. Is the dependent variable. So we know independent and dependent. So then the second part is describe how the average number of rentals changed over the year. Well, how did the video rentals change? What's the change in video rentals? Well, how many video rentals about do we end with? How many video rentals do we have in the last year about?
110.
About 120 or so. And how many did we start with? And you can check on your paper what's the computer. About how many did we start with?
380.
380 or so. That's not a bad estimate. So what's 120 minus 380?
260.
It goes down or is negative 260 rentals. Okay, well that doesn't tell us a ton unless we have some context so we know like over how many years this happened. Okay, so then what's the change in time? What year did we end? Well, 6. We started in year 0, so we've gone 6 years in total. Okay, so then what's the rate of change? About how many rentals per year, on average, are we losing? Oh, well, we can get an average rate. We saw from last class, we get an average rate by taking, say, how about 260 rentals over 6 years would give us an average rate of change. What's our unit rate of change then? How are we going to find the unit rate of change? Or how many rentals in 1 year are we losing? How are we going to get that unit rate of change? What do we got to do? What's the process for finding unit rate of change? Divide what?
26
By 6. Okay, so divide negative 260 by 6 and tell me what answer we get.
43.3.
So negative 43.3 repeating about
Yeah.
rentals for 1 year. So your average rate of change should be about negative 43 1/3 per year. So 2006 is less than that.